So here is our question. In a circle of diameter 40 centimeter, the length of a chord is 20 centimeter. Find the minor arc of the chord. So the question is, we got a circle. See, suppose this is our circle. This is our circle, and let this be the diameter. You see, the diameter is given as 40 centimeter. So this length is equal to 40 centimeter. Let this be the center, and the chord, suppose you got a chord like this. Here is your chord. See, this length of the chord is equal to 20 centimeter given. See, since this is the diameter and which is of 40 centimeter length, the radius will be 20 centimeter. So this length will be 20 centimeter, and similarly this length too will be 20 centimeter. So this form this ABC, this triangle forms an equilateral triangle. This is an equilateral triangle. So this angle will be 60 degree. So you have to find, you are asked to find the length, minor arc AB, that is this length. You need to find this length, L. So you have that formula, arc length L is equal to radius into theta, central angle. This R is the radius of the circle, and this theta will be 60 degree. Here the theta is not in degree, it must be in radians. So you have to convert that theta into radians. 60 degree into how will you convert 60 degree? You have to multiply it with pi, then divide it with 180. This 3 times, so your answer will be pi by 3 radian. So the angle is pi by 3. So therefore the length of the arc L is equal to R is 20 into pi by 3. So the length of the arc is 20 pi by 3 centimeter. Clear? Now the second question is, see, if in two circles arc of the same angle subtend 75 degree and 60 degree and 75 degree at the center, find the ratio of their radii. So how will you find this? See, this central angles are 60 degree and 75 degree, and they subtend the same length. So see, suppose this be our circle. This be the circle, and you are asked, you are given, if in two circle arc of the same length, if in two circles, so you got two different circles. See, let this be another circle, and arc of the same length. See, so you have two angles, since two angles 60 degree and 75 degree. Suppose this be 60 degree and this one be 75 degree. 75 degree. 75 degree. You are given this length AB is equal to this one PQ. Suppose this be the center C, this one T be the center of the circle. You are given this length is equal to this one. So let this be, for convenience, let take this as L1 and this one as L2. So you have L1 equal to L2, that is given. But L1 equal to R1 into theta 1. Similarly, L2 equal to R2 into theta 2. Here, the radius is given as two circles into circle of same length substance. No, you need to find the ratio of the radius. So, R1 by R2 is equal to theta 2 by theta 1. Here you don't have to convert it into radians because this is a ratio. So you either take it in degrees or in radians. Either way you won't get the wrong answer. So theta 2 is equal to 75 and theta 1 equal to 60. Since 15 is common for both, this 5 times 15 is 75 and this one 4. So 5 by 4 is the answer. That is ratio R1 is to R2 equal to 5 is to 4. So 5 is to 4 is the answer. Now the next question. Find the angle in radian through which a pendulum swings if the length is 75 centimeter and the tip describes an arc of length A. See, you just need to apply the formula here. Here in the first case, 10 centimeter. Length of the arc is 10 centimeter and the length of see, suppose this be the pendulum. Let O be its center. The pendulum is swinging like this. Let A be its initial position and B be its final position. This is the length of the pendulum. See, this is the length. This length will form the radius. So R equal to length of the radius. Length of the pendulum. R is equal to length of the pendulum. So here R is equal to, in the first case, R is equal to in the first case the length of the pendulum remains the same. So in every case R equal to 75 centimeter. R equal to 75 centimeter. This be the length described by the pendulum, which forms our length L, arc length L. This is our arc length. So L in the first case is 10 centimeter. Clear? Yes, it is 10 centimeter. So you have to find the angle. So you can use the formula theta is equal to length of the arc divided by radius, which will give you 10 divided by 75. 5 is common, 2 by 15 radians. 2 by 15 radians. Now the second question, in the second case, length of the pendulum R remains same, R equal to 75, but here L is equal to 10, L equal to 15 centimeter. Here theta is equal to arc length 15 divided by 75. 15 1 times in 15 and 5 times in 75. So 1 by 5 radian. The third case, L is equal to, see, L is equal to 21 centimeter. So L equal to 21 centimeter. So theta is equal to 21 arc length by radius 75. See, 3 is common here. You can cancel 21. You can cancel. You can factor it 3. So 7 times 3 is 21 and 25 times 3 is 75. So 7 by 25 radian. Clear?